Let's learn how to solve exponential equations. Now, remember how I said we should memorize our squares and cubes? Memorize squares up to 25 squared and cubes up to 10 cubed. I don't know if I've mentioned that before, but in case I haven't, you should definitely do that. It'll make problems like this much, much easier for you. Because in order to do any problem like this, where we're solving an equation with exponents, you have to be able to rewrite one or sometimes both sides of an equation so that they have the same base. So this left side of the equation has a base of 6. I need to rewrite the right side of this equation so that it also has a base of 6. And right now it doesn't. It has a base of 216. But because you memorized your cubes all the way up to 10 cubed is 1000, you know that 216 can be rewritten as 6 to the third power, or 6 cubed. Because you memorized your cubes, you know that. Once you rewrite 216 as 6 cubed, this problem becomes like comically easy. One side is 6 to some power, and the other side is 6 to the third power. Now, what could x possibly be so that these two sides were the same? What number would have to go there so that these two sides were equal? And obviously the answer is 3. If the bases are the same, the exponents would also have to be the same, so x equals 3. As it turns out, 3 equals 3. So 6 to the third equals 6 to the third. So all we have to do is rewrite the equation so that the bases on each side are the same, and then we make the exponents equal to each other. Now, of course, they're not all going to be quite this straightforward. Let me give you an example of one that's not as straightforward as this. Let's make the exponent a little more complicated. So one side is 25 to the x minus 1 power, and the other side's just 5. So our goal is still the same. We need the bases on both sides to be the same. This side is 5, so I want to rewrite 25 so that it also has a base of 5. And because we've memorized our squares all the way up to 25 squared equals 625, we know that 25 is the same thing as 5 squared. 5 squared is 25. But we have to be careful here because this 25 was raised to the power of x minus 1. So this is 25 to the x minus 1 power, and it equals 5. So we know that the two exponents have to be the same. This exponent must equal this exponent, and of course 5 is just 5 to the first power. So the exponent on the left has to equal the exponent on the right. Well, the exponent on the right is easy, it's just 1. But what is the exponent on the left? And this is a power raised to a power. It's 5 to the second power that is then raised to the x minus 1 power. And what's our rule for power of a power? We multiply the powers. So 2 times x minus 1. We multiply the two powers together, meaning to solve this, we have to use the distributive property. So we do 2 times x, which is 2x, and we do 2 times 1, which is 1, with a minus sign in between. 2 times 1 is 2, not 1, with a minus sign in between. And now we solve this. So we'll add 2 on both sides. And it looks like we've got a fraction in our future here, which is okay. 2x equals 3. And then we'll divide both sides by 2. And it looks like our answer here is going to be, you can do 1.5 if you like. I am just going to leave it as 3/2. So 3/2 is the answer here, or I guess 1.5 if you're the weirdest person on earth. But 3/2 ends up being the answer. So in both of these problems, we solved them using the same technique. We made the bases the same, and then once the bases were the same, we set the exponents equal to each other, and then solve for the missing variable. And that's all there is to it. And I don't know if I've mentioned this before or not, but these become much, much, much easier when you have your squares and cubes memorized. Those first sets that I mentioned, much easier. Because if you don't have them memorized and you see 216, you're going to be sitting there doing trial and error for a while till you find what's the combination that gives me 216. Is it a squared? Is it a cube? What's the number? You're just going to be sitting there on your calculator trying a bunch of them. You'll have a much easier time if you just memorize the first handful. Memorize your squares up to 25, memorize your cubes up to 10. It's not just for exponents. You're going to use it for many, many, many things throughout math. To just memorize them right now, it'll save you a lot of grief in the future. Promise.